Algebra. So this PowerPoint is going to be a review. So we've already talked about graphing rational functions in class. So you can use this just to make sure that you understand everything. And once again, ask questions in class if you're not quite sure on something. So let's start off with the graph here. So if you have graph paper, now would be a good time to get it out. Put this on pause a little bit. We are going to take the rational function, something fairly simple, f of x is equal to 1 over x plus 4. Okay, so remember the vertical asymptotes have to deal with the domain. The domain on this one is everything except 4, because we can't divide by 0, so except negative 4. So at negative 4 then we are going to have an asymptote. So what we're going to do is go ahead and draw that in. So we're going to do a dashed line. So our function never crosses a vertical asymptote. Okay, so now we want to figure out if we have a horizontal one. So the horizontal comes from the degree. The degree of the numerator is 0. The degree of the denominator is 1. So if the degree is smaller in the numerator, then you have a horizontal asymptote at 0. So this kind of defines the region where we see the graph. We can go ahead and just do a couple of points. Let's look for the y-intercept. So just like with any other curve, the y-intercept, we plug in 0 for x. If we plug in 0, we get 1/4. So it's crossing here at 1/4. And then you could plug in, well, let's just say, let's plug in a -2. So if I plug in a -2 for x, I get a positive 1/2 for the y. And if I plug in a -3, I would get a positive 1. But an asymptote acts as a curve-fitting line, so our curve gets closer and closer to the asymptote. So to get these points, you can also graph it on the calculator. What's going to be very important for you to know is the vertical and the horizontal asymptotes and x and y intercepts. So that's going to be the main thing. Most of the other points and things like that, to see where the curve actually lies, you can get from your calculator. Okay, let's do a -5. So if we plug in a -5 for x, we get a -1 for the y. So it's in this region here. But go ahead and graph this on your calculator and see what it looks like there. Okay, so that's our first rational curve. All right, for the next one, let's take a look at this function. Let's go with f of x is equal to 2 over x squared minus x minus 6. Okay, so if we're looking for the domain on this one, we look to the denominator, and what we're going to have to do there is factor that denominator. So we've got x and x, factors of -6, whose sum is -1. We're going to have -3 and positive 2. So our domain is all real numbers except for x cannot equal 3 or -2. So in this case we have 2 vertical asymptotes. So at 3 we draw in 1, and at -2 okay. So you always get those vertical ones first of all, and those always come from the denominator, because we're concerned about, with a fraction, we cannot divide by 0. So those vertical asymptotes are related once again to your domain. All right, and then we want to look for the horizontal. So we compare the degree of the numerator and the denominator. So the numerator has a smaller degree than the denominator. So we're going to have a horizontal at 0 again. Okay, so this breaks it up into regions. So now we just need to find some points. So The y-intercept then is one that you can use, you can figure without a calculator. So the y-intercept, we plug in 0 for x. If we plug in 0 for x, we get 2 over negative 6. So we get a negative 1/3. So we'll plot that, 0, negative 1/3. And then you can take a look at the graph to see what's happening. I'm just going to plot a point. I'm going to do another one. So let's do like 1 is a fairly simple one to do. So in the denominator, we're going to plug in a 1 in for the x and see what the y value is. So 1 minus 1, those cancel, and then minus 6, so we get a negative 6. So we get 2 over negative 6, so it's a negative 1/3. So you can look to see what's going on, but more than likely, I guess I should have graphed this on the calculator to make sure. More than likely, you have a parabola here, and then we have, you can, why don't you go ahead and put this in your calculator to make sure. It's important that you understand the asymptotes because sometimes you might not know if the calculator, if you plugged it in right. So on this one, you would go 2 divided by, and then you'd put the x squared minus x minus 6 in parentheses. So when you graph it, sometimes your calculator doesn't give you a very good graph, but it's indicating that it looks something like this. All right. Now your curve will never ever cross a vertical asymptote. Sometimes it will cross a horizontal one, but for the most part, those asymptotes are just curve-fitting lines. So you know that your curves are getting closer and closer to those lines. Okay. Let's go on to our next one. We're going to take the function f of x is equal to x plus 2 over x minus 4. Okay, so without a calculator then, you're going to be responsible for the asymptote. On this one, we look, our domain is everything except for 4. So at positive 4, we have a vertical asymptote. And then we compare the degrees. The degrees in both the numerator and denominator are first degrees. So we use the leading coefficients, so 1 divided by 1. So we have a horizontal at 1. Okay. And then the y-intercept, so if we plug in 0 for x, we're going to get 0 plus 2 over 0 minus 4. So 2 over negative 4 is negative 1/2. So 0, negative 1/2. Okay, how about an x-intercept? So an x-intercept, we want the whole fraction to equal 0. And the only way the fraction is going to equal 0 is if the numerator is equal to 0. So we'll just take a look at this, and what makes that equal to 0 is negative 2. So our x-intercept is negative 2, 0. So we have this point here. So I would expect you to be able to show everything I have graphed there without a calculator. So the asymptotes, x and y intercepts if we have them. Okay. So you could look on your calculator and see, but this will give you a fairly good picture here of this one. Okay. Let's take a look at now the function f of x is equal to 2x minus 6 over x squared plus 2x minus 15. All right, before we can get started here, we need to do a little bit of work. We're going to factor. So in the numerator, our greatest common factor is 2. So we're going to factor that out. And in our denominator, we have a quadratic, and that factors as x. We need factors of negative 15 whose sum is 2, so plus 5 minus 3. Okay, so you would still put this whole thing in your calculator. To put it in the calculator, make sure and put parentheses around the numerator, divided by, and then parentheses around the denominator. But what happens when you go to graph it is that the x minus 3 cancel out, and instead of getting an asymptote at 3, we're going to get a hole in the graph. Okay, so we get one vertical asymptote from the x plus 5. So we would have a vertical asymptote at negative 5. Our domain, however, is still going to be all real numbers except for negative 5 and positive 3. But once again, because the x minus 3 canceled out, instead of an asymptote, we have a hole. So we have a hole in our graph at 3. Okay, so let's find our y-intercept. So to get the y-intercept, we plug in 0 for x. If I plug in 0 for x, in the numerator I get a negative 6, and in the denominator we get a negative 15, and that'll reduce to a positive 2/5. So at 0 it's 2/5, maybe about there. And then let's look at the y-intercept. So we plug in 0 for y, the x-intercept. To get the x-intercept, plug in 0 for y. So we want our fraction, we want the 2x minus 6 over x squared plus 2x minus 15 to equal 0. And the only way a fraction is going to equal 0 is if the numerator is equal to 0. So we can ignore the denominator right now. Okay, so if I plug this in though, I get 2x is equal to 6, and then x is equal to 3. But what did we say earlier? We said that there would be a hole at 3. Okay, so looks like that's where our hole occurs there. Now that doesn't happen very often. Okay, so now what we're going to do is plug this into your calculator and see what it looks like. Oh, and then we also need to look at the horizontal asymptote. So the degree in the numerator is 1. The degree in the denominator is 2. So it's a smaller degree in the numerator. So that means we have a horizontal at 0 again. Okay, so those are asymptote. And then we can look at the calculator to see what the points look like, what the curve looks like. But remember, it's going to get closer and closer to your asymptotes. And actually just having one point, you kind of know, oh, well, this is where they want it located at. Okay. So hopefully that's a good wrap-up of how we graph rational functions. So make sure that you know how to find both vertical and horizontal asymptotes and how to get the y-intercept and the x-intercept if you have them. All right. Good job, you guys. I will see you in class.